Hello everyone, welcome to my channel. In this video, I will explain about dimensionality reduction. So this concept belongs to machine learning. First we'll see the definition. Dimensionality reduction is a machine learning technique used to reduce the number of input features or columns while keeping the important information. So what is the meaning of dimensionality reduction? The meaning of this dimensionality reduction is it is used to reduce the number of input features. Very important. So in a dimensionality reduction, just we are going to reduce the number of input features. So remember all of you, what is the meaning of features here? Features nothing but column. When we have the large amount of data, what is going to be happened? It is very difficult to handle. Hence we are going to reduce the columns which are not required. So while keeping important information. So when the dimensionality reduction is there, this concept nothing but we are going to reduce the unnecessary data. We are going to remove the unnecessary data. So this is called as what we say dimensionality reduction technique. So let us assume one example you can see on the screen. So here let us assume a data set is having 100 features. So let us say there are 100 columns are there. Many columns are duplicate or else less useful. By using dimensionality reduction, convert into 10 or 20 important features. So what is the purpose of this dimensionality reduction? Just we are going to reduce the redundancy or else we are going to remove the unnecessary columns. So I have 100 features are there. So I want to reduce into this 100 are there. I want to reduce into 10 or 20. So this is called as what we say dimensionality reduction. Remember all of you, when you remove the features, you need to keep important features as well, and we need to remove the unnecessary features. Okay, now let us see the uses of this dimensional reduction. The first one is called as faster computation. Okay, why it is having faster computation? Because when we have 100 features or 100 columns, when I reduce into 10 or 20 columns, it is going to reduce the burden of the database as well as it will improve the computation. Okay, so second one is the reduces complexity, and third one is the overfitting. So last one is the it is also help in visualization. Very important. Okay, so these are main 4 uses of dimensionality reduction. Now let us see how we represent the dimensional reduction. So we have 2 types of techniques are there in a dimensional reduction. First one is called as feature selection and second one is called as feature extraction. Okay, so in this video I will explain about feature selection. Next video I am going to talk about the feature extraction. So let us see what is the meaning of feature selection. So in the feature selection, we select only the important features and remove irrelevant columns. Okay, so we are going to remove the irrelevant columns. Let us say the example is there. Example is house price prediction. Now I want to predict the house of the price. So what are the columns required for this one? You observe, in order to in order to predict the house price, let us say I included initially the first one is house ID, owner name, area, number of rooms, location and price. So does all these factors will impact on house price? No, because this house ID is not required. House ID is not at all related to the price of the house. Okay, as well as this owner name is also not required. So I will remove these two. But if you see area is also important. Okay, second one is the area means the size of the location. Second one is the number of rooms. This is also important. Location is also important, where it is located, and price. So these 4 are very very important. So that's why out of 6 I will keep only these. So first one is the area, second one is the number of rooms, and third one is the location. Okay, so we can also write this here, price also. So this is called as what we say dimensionality reduction. So we are going to remove the unnecessary columns. We are going to keep only the important or necessary things. So we'll see, remember all of you, in feature selection completely there are 3 methods are there. The first one is called as a filter method, second one is called as wrapper method, and third one is called as embedded method. In filter method, the first one is correlation, second one is the chi-square test, third one is the ANOVA, fourth one is the information gain. In wrapper, again we have forward, backward, bidirectional elimination, and in the embedded we have lasso, elastic, and ridge regression. Let us discuss one by one. So first we will go with the filter method. So what is the meaning of filter method? Select the features based on statistical measures. Very 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 important. So filter method nothing but we will going to discuss on the statistical measures. So let us have in this the key techniques are, first one is the correlation. Okay, so it measures the relationship between the features. Remove highly correlated features. Avoid redundancy. So when we remove this correlated features, we get some redundancy. We can remove the redundancy. Let us take the example for filter method. So you see on the screen, the example is data set is called as student marks. So when there is something called as student marks, what are the columns I have mentioned in the table? Age, study hours, mobile usage, and marks. After checking the correlation, okay, study hours is strongly related to the marks. This is something like when you do hard work 10 hours, you may get one type of result. When you do 5 hours of hard work, you may get one type of result. So in this, the study hours is mandatory. But if you see mobile usage, okay, weak selection. So what we have to do, you need to remove this something called as a mobile usage. So we may not say mobile usage is depends on the marks. Okay, so this is called as a first technique. This is called as correlation. Second one, we go for chi-square test. So this is used for categorical data. Okay, so what is the meaning of categorical? This is nothing but when I say category, so when you go to the shop, so when there is a red color is there, the customers are going to purchase. When there is a blue color, the customers are not purchasing. So this is called as what we say categorical data. So does the color affecting buying? Observation, red is yes, blue is no. So strong relation exists. Okay, so conclusion, color is important feature. So this is called as what we say chi-square test. So it's all about the depends on the categorical data. So categorical means there are 2 categories are there. First data is red and second data is blue. Okay, so when it is red, the customer is going to purchase. When it is blue, the customer is not going to purchase. So the conclusion is color is important feature. We need to keep that one. So next one is the ANOVA. So what is the purpose of ANOVA? ANOVA is used for numerical data. Okay, so in the previous we discussed about the chi-square test. It is about the categorical, but when it comes to ANOVA, we talk about the numerical data. Finds the features that affect the target variable. So now we'll see the example for ANOVA. Let us say the person who studies 2 hours, he received 40 marks. Who studied 5 hours, he received 70 marks. Who worked hard 8 hours, he received 90 marks. Does the study hours affect on marks? Yes, because 2 hours 40 minutes, 2 hours 40 marks, 5 hours 70 marks. So this is always increasing order. Okay, so this is called as what we say ANOVA. Study hours give different marks. Yes, so you need to keep this one. So this is called as what we say ANOVA method. Okay, so study hour is the important feature, so you need to keep. So next one is the information gain. It measures the how much information features gives here. Okay, so it is used in the decision trees. So we talk about now information gain, how much information a feature gives. So when we select any feature, how much information that will be given by that feature. Okay, so let us see here study hours result. So when the study hours are high, the pass percentage is there. When the study hours is more or less, the percentage less. So study hours give the best useful information about the result. So original observation, high is pass, low is fail. So what is the conclusion? High information gain the keeping the feature. So always remember, we need to keep the feature or remove the feature. So based on our requirement, we need to keep or remove the feature. So second feature method is called as wrapper method. It selects the based on the model performance. Okay, so in this the data features are study hours, sleep hours, mobile usage. So the target is marks. So we select the features based on the model performance. So in this remember, this study hours is required. Okay, so mobile usage is not required. We may not say something like always mobile usage is related to marks. So simply we can remove this part. So this is called as what we say wrapper method. Okay, so we talk about the till now this one. We completed till now correlation, chi-square test and ANOVA information gain. Now the second one is here. This is called as forward selection. Okay, so this forward selection, this one. So observe all of you. Now we come to wrapper method. So this wrapper method is called as this one. Okay, so in the wrapper method, the first one is called as forward selection. So what is the meaning of forward selection? Adding the features one by one. So we completed first one. Now we go for second one. That is called as a wrapper method. Now we go for forward selection. So what is the meaning of forward selection? Adding the features one by one. So features, let us see. The columns are study hours, attendance and sleep. So first to pick up, what are the important features to have great or good marks? So first one is the study hours are important. Second one is the attendance also important. So adding sleep, we cannot say if you sleep 12 hours or 13 hours, can we say good marks? No. So you need to remove this one. So last one is the final. So what is the final? Study hours plus attendance. So these two are important features. So this is called as forward selection, adding the features one by one. So first we will add study hours, then we add attendance. You observe, first we add study hours, then next we add attendance. But if you see adding the sleep, not useful because we may not estimate. It depends on the marks. Okay, next second one is the backward elimination, removing the features one by one. So in the forward elimination we added, in the backward we remove the features one by one. So what is the first feature? You can observe. So initially we will add all these. You observe all features like study hours, attendance, sleep. So remove sleep X, least useful. So out of study hours, attendance, this is the least useful. You remove this one. So this is called what we say backward elimination. In the forward elimination we are adding. In the backward elimination we are removing one by one. Okay. So both directional elimination, both adding and removing step by step. So the this is called as a study hours plus attendance. So in this we required only study hours plus attendance. So third one is called as bidirectional elimination. So remember, when we have forward direction we have added, when we have backward direction we remove, but when we say bidirectional we can have both adding and removing step by step. So you see, let us say features are study hours, attendance, sleep. So we can add and remove. So starts with the none, we don't have any features. Add study hours initially, add attendance initially. So check. Now you need to check whether the sleep is not useful. Yes. Can we say sleep is useful for marks? No. So you may not add. If already added, you need to remove. So this final answer could be study hours plus attendance. So this is called as what we say bidirectional elimination. In the feature selection, the second one is wrapper method. There are three methods are there. First one is the forward, second one is the backward, third one is the bidirectional elimination. Now we have the third method is there. The third method is called as feature selection happening during the model training. Okay. So the first one is lasso regression. So what is the meaning of lasso regression? You observe, it is nothing but we can see on the screen least, absolute, strinkle and selection operator. So it assigns the weights to the features. So study hours. So we'll have something called as weights in this concept. So we need to have, let us say there are different features are there. Study hours, age, mobile usage. When there is called as study hours, we need to add some weight. We'll add some weight. After, let us say the weight could be 0.8, 0.3 and 0. So why we need to add 0.8 for this study hours? Because this is highly related to the marks. But if you see age, always we may not say, that's why I reduce the marks, that is a weightage 0.8 then 0.3. But if you see mobile usage, the weightage could be 0 because we may not have mobile usage related with the marks. So this is called as what we say a lasso regression. So lasso automatically remove the less important features. Okay. So this will automatically remove the less important features. So this is called as what we say lasso regression. In the embedded, the second one is called as a ridge regression. It is a linear regression method that adds penalty term to reduce the large coefficient values and present overfitting. So in the previous second one, in the previous first one, we added weights, but here in the ridge, we are going to add to have a penalty term. Okay. So to reduce the coefficient values and prevent overfitting. So we are using something called as a penalty in the ridge regression. So last one is the elastic net. So this adds the both ridge plus lasso. So when you say lasso, we are going to add weights in order to remove the unnecessary features. So in the ridge, we are going to add penalty. Okay. So this is all about the feature selection. Very important. If at all you need notes, you can ask me. So we complete this feature selection. In the next video, I will explain about next concept. So the concept is we completed here till now this feature selection. Now we go for in the next video, that is forward selection. Okay. Thank you for watching this video. Please subscribe my channel. Thank you.